We are starting the last section of Chapter 7, so this will be the last section that we learn for the semester. So just to go back over what we are trying to do for Chapter 7. So we're trying to solve oblique triangles, and we've talked about case 1, where you have one side and two angles, whether that angle, whether the side is between the two angles or not. So side angle, or angle, side angle. We've talked about case 2, which is where we have two sides known and then one angle that is not included between the two sides. So that is side-side angle. This is the case that leads to more than one triangle, or the ambiguous cases. So we're going to talk about case 3 and case 4 today. So case 3 is you have two sides and the angle included between them. Okay, so that's side, angle, side, or three sides are known. Side, side, side. So section 7.3, we're going to talk about the law of cosines. So first let's derive the law of cosines to understand where they come from. So one thing to note is the triangle side length restriction. So in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Okay, so to derive the law of cosines, we're going to let our triangle ABC be an oblique triangle, whether it's acute or obtuse. And then we're going to look at the coordinate system so that our vertex B is on the origin. Okay, so you see right here we have our XY Cartesian plane. So B is right here at the origin, and then side BC is along the positive x-axis. Okay, so we're going to let the point XY be the coordinate of the vertex A. Okay, so we're going to let XY be this point here, A, and then the following are going to be true for angle B. Okay, so whether B is obtuse or acute, these will still hold true. Okay, so sine of B, okay, so we're looking at this right triangle here. So sine of B, which is opposite over hypotenuse, so sine of B would give me y over c. And then cosine of B is going to give me adjacent over hypotenuse, so that would be x over c. Okay, so if I solve this for y, I would have y equals c times sine b. So c times sine b, and then I would have x equals c times cosine b. Okay, so this is x and y, so that's why we have our coordinates up here of c cosine b, c sine b. Okay, and I'm going to write that again. So the coordinates of point A then become so x c cosine b, and then c sine of angle b. Alright, so then point C has the coordinates A, 0. Okay, so looking from here, the x value is the length of A, and then y is 0 because we are on the x-axis. AC has the length of B, and then again point A has the coordinates C cosine B, C sine B. Okay, so we can use this information and write and use the distance formula to write an equation. Alright, so first we have B is equal to the square root. Okay, so both of our x values first. So we have C times cosine B minus A squared. Okay, so x2 minus x1 squared plus y2, which is C sine B minus 0 squared. Okay, this will be y1. So if we square each side, so if we square B and then we square this right side, our radical is going to go away. So we're just left with what's underneath the radical. So B squared equals C cosine B minus A squared plus C sine B minus 0 squared. Okay, and then here, C sine B minus 0 squared is the same as C sine B squared, okay? because subtracting 0 is not going to make a difference. So we just have c sine b squared. Alright, so now we want to actually multiply these out. Okay, so if I multiply these out, I'm left with c squared cosine squared b minus 2 times ac times cosine b, and then plus a squared, and then this part squared is going to give me c squared sine squared b. Alright, so I can rewrite this. Okay, so notice here I have c squared times cosine squared b and c squared times sine squared b. Okay, so I'm going to bring the a squared out front, and then c squared times the cosine squared b here, plus the sine squared b from there. And then I'm just going to bring this extra bit down of times 2ac cosine b. Okay, so then if we use one of our fundamental identities, here we have a Pythagorean identity. So cosine squared b plus sine squared b equals 1. Okay, so then we have a squared plus c squared times 1 minus 2 times a times c times cosine b. Okay, so then our first formula, b squared, is equal to a squared plus c squared minus 2 times a times c times cosine of b. Okay, so this is the two sides squared minus 2 times the sides times the angle in between, cosine of the angle in between those two sides. Okay, so this is a result of one of the possibilities of the laws of sines. Had we used a different angle, we would have gotten a different possibility. Same results, just the variables would be rearranged. Okay, so law of cosines. So these are the three laws of cosine. So you can see what we solved for a second ago was b squared. So then you also have a squared, which would be the other two sides, minus 2 times bc times those sides and the angle in between them. Okay, so it's the square of a side of a triangle. So the square of a side of a triangle is equal to the sum of the squares of the other two sides. Okay, so here we have a and then bc. If we have b, then we have a and c. If we have c, then we have a and b. Okay, and then minus twice the product of those two sides. So here we multiply 2 times whatever sides that were squared. And then it's going to be the cosine of the angle included between them. Okay, or it's going to be cosine of whatever angle that's on this left side. The angle that corresponds to this side, I should say. Alright, so example 1. 2 boats leave a harbor at the same time, traveling on courses that make an angle of 82 degrees and 20 minutes between them. When the slower boat has traveled 62.5 kilometers, the faster one has traveled 79.4 kilometers. At that time, what is the distance between the boats? Okay, so let's draw a diagram. So we'll start at the harbor. I'll call the harbor C. Okay, so the slower boat went this way, and we'll say the faster boat went this way. Okay, so I'm going to call this A. This is the slower boat, and this will be B, the faster boat. Okay, so we know that the angle between them, okay, so they made an angle of their course was 82 degrees in 20 minutes. We also know the slower boat traveled 62.5 kilometers, okay, so that means that this side is 62.5 kilometers, which is side B, since it's opposite of B here. And then side A would be the length of the faster boat. Okay, so the faster boat traveled 79.4 kilometers. Okay, so if we draw our triangle here, we want to know what is the distance between the boats. So we want to know what is C. Okay. So that is our goal. We want to know what is the length of side C, or the distance between the boats. Okay. And then I also want you to notice that we were given, so we were given this side here, this angle, and then this side. So this is a side angle side case. Alright, so we want to find C. So we're going to use one of the law of cosines. So we're going to use the C squared. Okay, so we're going to use this one right here. So we're going to use C squared equals A squared plus B squared minus 2 times A times B times cosine of C. Alright, so if we just plug all of these values in, okay, so A is 79.4 kilometers, so we have 79.4 kilometers squared plus 62.5 squared. Okay, and then we have, I'm going to go down bottom, so I don't have enough room to write it all. And then 2 times A, so 2 times 79.4 times 62.5 times cosine of C, which is 82 degrees and 20 minutes. So cosine of 82 degrees and 20 minutes. Alright, so I'll put that all in my calculator, and then I get C squared is approximately 8,886.5 kilometers. Okay, the next step is to take the square root of both sides. Okay, so in our law of cosines we have C squared, but we want to know what C is. So take the square root of both sides. So then we would get C is approximately 94.3 kilometers. And remember that we're talking about distance, so this is going to be the positive value when you take the square root. Okay, so then that would be our answer. So C, so the distance between the two boats is approximately 94.3 kilometers. Okay, so we have example 2. Solve triangle ABC if B is 73.5 degrees, side A is 28.2 feet, and then side C is 47.6 feet. Alright, so let's draw a triangle here. Okay, so A, B, and C. Okay, so angle B is 73.5 degrees. Side A is 28.2 feet. And then side C is 47.6 feet. Okay, notice again we have side, angle, side. Alright, so to solve this, and I'm going to go ahead and write B here. To solve this means that we need to find out A, angle A, side B, and angle C. Okay, so the three measures that we are missing. Okay, so we have side, angle, side, so we can use the law of cosines to find side B. So we're going to do that first. So using law of cosines, we're going to find side B. So we're going to use the formula B squared equals A squared plus C squared minus 2 times A times C times cosine of B. So that gives me B squared is equal to, A is 28.2, so 28.2 squared, plus side C is 47.6 feet, so that's 47.6 squared, minus 2 times A again, so 28.2, times C, which is 47.6, and then cosine of angle B, so cosine of 73.5 degrees. Okay, so all I did was just plug in the values that we were given. So then I have B squared is approximately 2,298.5 feet. And then B, so I need to take the square root. And so I would get approximately 48 feet. Okay, and notice these are, your measures are being squared here. So this is 28.2 feet squared. So you would get feet squared here, but when you take the square root, it's going to go back to whatever measure that you are working with. All right, so B is 48 feet. So now we need to find angles A and angle C. Okay, so with the information that we're given, to find angle A or angle C, we need to use the law of sines. Okay, it doesn't matter which angle you solve for first. It doesn't matter if we solve for A or C. I'm just going to go ahead and do A first. So we have side A over sine A equals side B over sine B. Okay, so we have 28.2 over sine of A. We don't know A. And then side B is 48 over sine of 73.5. Okay. So then that gives me that sine A is equal to 28.2 times sine of 73.5 all over 48. And then plug that into the calculator and you get sine A is approximately 0.5633. Okay, and remember that we are looking for angle A. So we're going to take, so we're going to solve for A. So we're going to have A equals sine inverse of 0.5633, which gives me that A is approximately 34.3 degrees. Okay, so if I add that into our chart here, A is 34.3 degrees. Then to solve for C, you can either use law of sines again, or you can use the angle sum property. Okay, so this property just says all the angles have to equal up to 180 degrees. So that means that C is equal to 180 minus 73.5 degrees plus 34.3 degrees. Okay, so C is 72.2 degrees. Okay, so once you find all of the measures, your triangle is then solved. Alright, so example 3. So solve triangle ABC if A is 25.4 centimeters, side B is 42.8 centimeters, and then side C is 59.3 centimeters. Okay, so notice here we're not given any angle measures, we're only given sides. Okay, so this is a side case. Okay, so I draw my triangle. I'm going to label it my angles and then my sides. And then I'm going to fill in the information that's given. Okay, so A is 25.4 centimeters. B is 42.8 centimeters. And then C is 59.3 centimeters. Okay, and I want to solve the triangle, so I need to find out what each angle is equal to. Alright, so using our law of cosines, and in this case you could use any of the law of cosines, just whichever angle that you want to solve for first. So it really doesn't matter, just choose one and then go with it. So we're just going to use this formula, c squared equals a squared plus b squared minus 2 times a times b times cosine of c. Okay, so since we know all of the sides, what we are solving for is going to be c. And then you'll see how that plays out. Okay, so let's plug in everything we know. So c is 59.3, so that's squared, equals 25.4 squared plus 42.8 squared. Okay, and then minus 2 times 25.4 times 42.8, and then times cosine C, okay, because we don't know what C is. That's what we're looking for. Okay, so solving for cosine C. So this gives me cosine C is equal to 59.3 squared minus 25.4 squared minus 42.8 squared all over negative 2 times 25.4 times 42.8. Okay, so all I did here was subtract this value and this value to the left side, and then to get cosine C by itself, I divided by what was remaining here. Okay, so I just rearranged the formula so that we can have cosine C on the left side. Alright, so this is going to give me cosine C is equal to negative 0.4781. Okay, so if I solve for C, I have C equals cosine inverse of 0.4781. Okay, C is approximately 118.6 degrees. So I'm going to go ahead and write that in. So C is 118.6 degrees. Alright, so then law of sines. Okay, so this is what we're going to use next, because we have angle side side or side side angle. So we have other cases that we can use now. So the only thing that we're missing are angle A and B. You could also use law of cosines again, just whatever way works for you. But we're going to go ahead and do law of sines. So we have B over sine B equals C over sine C. Okay, we do have to solve for, we do have to use C in our law of sines because that's the only angle that we do know. Okay, so once we plug everything in, we have 42.8 over sine of B, because we don't know what angle B is yet, equals 59.3 over sine of 118.6 degrees. So this gives me that sine B is equal to 42.8 times sine of 118.6 degrees divided by 59.3. Alright, so I'll plug that into my calculator and I have sine B is approximately 0.6337. Again, we're solving for the angle, so we're going to take the inverse. So B is equal to sine inverse of 0.6337, which gives me that B is approximately 39.3 degrees. Okay, and then for the last angle, angle A, so the last angle that we are missing, we are going to use the angle sum property again. Okay, so that means that A is equal to 180 degrees minus 39.3 degrees plus 118.6 degrees. Okay, so angle B and then angle C. So A is 22.1 degrees. Okay, so we found all of our angles, so now our triangle is solved. Okay, example 4, find angle C to the nearest degree for the truss shown in the figure. Okay, so we are only looking for angle C, so we want to know what is angle C. So looking at this picture here, we are given the sides, all of the sides. So this is a side case. Okay, and then we just want to label them. So remember, the side is across from A, B is across from angle B, and then side C is across from angle C. So since we are looking for angle C, we are going to be using the law of cosines formula. C squared equals A squared plus B squared minus 2 times A times B times cosine of C. Okay, so this is the only formula that has the angle C in it for law of cosines. So from here we just plug everything in. So we have 9 squared equals 6 squared plus 11 squared. We did that backwards. 11 squared is, 11 is A and 6 is B. So 11 squared plus 6 squared gives you the same thing. 2 times 11 times 6, and then times cosine of C. Okay, so this gives me 81 equals, I'm going to bring this here, 121 plus 36, and then minus 132 times cosine of C. Okay, so after adding these together, I have cosine C is equal to negative 76 over negative 132. Okay, so I added these two together, subtracted that amount from 81, and then divided by the negative 132 to get cosine C by itself. So cosine C is approximately 0.5758. And then again, we're looking for the angle C. So we're going to take the inverse. So that means that C is approximately cosine inverse of 0.5758, which then gives me C is approximately 55 degrees. Okay, so C is 55 degrees. And then that's all they wanted us to solve for was angle C. Okay, so if it says solve triangle, you have to find all of the measures. In this case, they only ask for one specific angle. Alright, so on this last page, we have the 4 cases for solving oblique triangles. So this is going to cover all of chapter 7 that we've done so far. The case 1, case 2, case 3, and case 4. So side angle angle or angle side angle. This is just, finding the angle using the sums, because in this case you're given 2 angles. So you can go ahead and find the third using the angle sum formula, and then use the laws of sines to find the rest of the sides, okay, the other 2 sides that are missing. Case 2, this is the ambiguous case. This is where there may be no triangle, 1 triangle, or 2 triangles. So in this case, you will find the angle using the law of sines, because you're only given 1 angle and 2 sides. Okay, and this angle is not between the 2 sides, or otherwise that would be case 3. Okay, so you want to find one of the angles that is missing using the law of sines, and then find the remaining angle using the angle sum formula, and then finding the remaining sides using the law of sines. Okay. Again, remember, 2 triangles exist. This is where you will have to add the 180, the supplementary angles to see if there is a second triangle. Case 3, one of the cases that we talked about in this section today, you are given 2 sides and the angle between them, so you can find the third side using the law of cosines, and then find one of the other angles using the law of sines, just like we did, and then the last angle using the angle sum formula. So exactly what we did in this section today. As well as case 4, if you're given 3 sides, then you can find the angle using the law of cosines, and then find either remaining angle using the law of sines, and then the last one using the angle sum formula. Okay, so this is like example 1 and 2, and this is examples 3 and 4. Okay, and the last thing that we're going to talk about is Heron's formula for the area of a triangle. Okay, so this is if you're given 3 sides. So this is, or you'll need 3 sides, so side, side, side. So if I have a triangle with sides of lengths A, B, and C, then we have the semi-perimeter. So S is equal to 1/2 times all of the sides added up together. Then we can find the area of the triangle. So the area is given by the square root of the semi-perimeter. Okay, so this is S from here, times the semi-perimeter minus the first side, times the semi-perimeter minus the second side, times the semi-perimeter minus the third side. Okay, so basically you'll just find S and then you'll plug into the formulas. So for example 5, we have the distance as the crow flies from Chicago to St. Louis is 262 miles. From St. Louis to New Orleans is 599 miles, and from New Orleans to Chicago is 834 miles. What is the area of the triangular region having these 3 cities as vertices? So if I just draw my triangle here, okay, so we'll say this is St. Louis, we have New Orleans, and we have Chicago. Okay, so from Chicago to St. Louis is 262 miles. From St. Louis to New Orleans is 599 miles. And then from New Orleans to Chicago is 834 miles. Okay, so these are our 3 sides. Okay, so for our semi-perimeter, okay, so we have S is equal to 1/2 times all of these sides added together. So that means S is equal to 1/2 times 834 plus 599 plus 262. Okay, so I just added all of these sides together and then divide by 2. So S is approximately, or S is 847.5. Okay, then you're going to plug this into the formula. So the area formula, which is the square root, S times S minus A times S minus B times S minus C. Okay, so here we have A is equal to the square root. So we have S, which comes first, so 847.5 times S minus A. So that's 847.5 minus A. So in this case, it doesn't actually matter which side you label as A, B, and C. So just make sure you use all of them. So we'll do 262 and then 847.5 minus 599 and then 847.5 minus, let me erase that, minus 834. Okay, so after you multiply all this out and then take the square root, you're going to get A is, we'll say, 40,800 miles squared. Okay, so don't forget to do the miles squared. Let me rewrite that. 40,800 miles squared. Okay, don't forget to put the miles squared when we're talking about area. Okay, so it's important to have that measurement there. All right, and that is the very last bit for this semester. Okay, so I just wanted to add this on the end regarding example 3. This should not be positive inside of here. This should be a negative. Okay, so then cosine inverse of negative 0.4781 is going to give me 118.6 degrees.